Okay, good morning everyone and welcome to grade 7 coding. It is the 7th of July, the entire day today, and we are doing functions in the harvester. So I think what I'm going to do is just run through the normal things that we run through every day, and then I want to get into the coding relatively quickly. But there are some things on the slides that we have to discuss beforehand, because the way that they've structured this in the new 2020 version of Code.org's Express course, things look a little bit differently. And you need to understand that before we can continue into this lesson. So first things first, chat box is there for me to share links with you and for you to ask questions and answer questions if I ask them, and if you need to ask them, okay? So anything that you ask me that is not related to the lesson, I will try to work that into the next lesson if that is at all possible. So that's basically the chat box. Please, nobody post any links in there. Only I should be posting links in there. And this is because we try to take your I do take your online security very, very seriously. I've been working online for many years, and I do know the exact risks that are associated with being online. So I will do everything and anything from my side to keep you safe while you are in a lesson with me. Okay. Your video cameras, please try to keep them off. Obviously, accidents happen, especially if you are using a smaller device like a phone, but try to keep them switched off. If they do turn on, myself and the host will switch them off on your behalf, and then we ask you to try and keep them off, because it doesn't, when it's on, I cannot see my screen, right? So I'm not capable of teaching you the content or discussing it with you because I can't see it. And then before we start, I just have to give a shout out to our awesome hosts that we have here at Africa Teen Geeks and at the STEM Digital School. Without them, these lessons are not possible. These guys are working tirelessly behind the scenes to get on here, host it, organize everything, manage links, manage passwords, manage participants, and then they do the YouTube uploads as well. So, I mean, without them, really, this entire thing wouldn't be able to run as smoothly as it is currently. They also offer technical support to teachers that don't know the technical things. So I just want to, from my side, give a shout out and a thank you to them. Right, so we are doing functions in Harvester. Let's get going. So here's that same quote that we had yesterday. And remember, I believe, and it's been proven, that repetition is the mother of all learning. So we will repeat this a couple of times this week. In 15 years, we'll be teaching programming just like reading and writing and wondering why we didn't do it sooner. And this was said by Mark Zuckerberg in 2014 already at the Computer Science Education Week hosted by Code.org. So it just goes to show that this was 6 years ago that he made this statement. And here we are today, 6 years later, not even 15 years later, and we are teaching coding. And we are attending coding lessons, right? So I think he actually has a much broader view, and there are a lot of people that are advocating to incorporate computer coding into almost any STEM subject. But for the time being, just having a solid curriculum that we can use is going to go a long way. So here are some terms that I want to just discuss with you. Yesterday we looked at loops here at the top and at functions, but loops are easy, so I think you have that down. But there's something that I want to mention here, and this is a sequence, right? So you will hear me speak about a sequence often, and I refer to some segments of code as sequences. So I want you to really just understand the definition of what a sequence is. So a sequence is the main logical structure of algorithms and programs. So what that means is that is the actual part of the code, and it might be the entire program is written in a sequence, and if you use that entire program and integrate that into another program, then that first program's coding becomes just a sequence within a larger program or a larger algorithm. But the sequence, very simply put, is when we combine a bunch of lines or blocks. We're using block lead to code. So if we take a lot of blocks and we put them together to follow in order one after the other to let or make something happen or to calculate something. Okay, to perform a task or to calculate something. So that is what a sequence is. Now, a sequence can consist of functions, variables, loops, many different things that you can have within a sequence, right? Just the plain action blocks. So it doesn't necessarily, there isn't a rule that states that a sequence has to consist of these things. Sequences can be 20 blocks long or they can be 2 blocks long. So it's all going to depend on what you're going to use it for. So that brings us to the next one, is functions. So functions is when we take a sequence like that, as we've just discussed, and we realize, okay, a sequence function is a sequence of code that performs a task or calculates a value. So if I'm going to be creating a video game as an example, or an app on the cell phone, there will be certain sequences of code that will be present in different areas of the app. So for example, let's say something as easy as dragging and dropping. Okay, so let's say you're playing a game like Tetris, where you, that's a game, but it is also an app if it's on the cell phone, where you are actually going to click on some things to turn the little blocks as they come down, and you might be dragging them with your finger across the screen to change the position of where they will land. So that action of clicking on them to turn them, and that action of dragging them across the screen with your finger, that could be coded into a function, right? Because there will be different times that you are going to use that same sequence. So if you assign or define a function right at the beginning when you start your program or app or game development, and you say to that function, all right, the drag and drop function consists of a sequence that would say something like, if the thumb touches here, then do this, or something of that order. So there might be 20 lines of code within that drag and drop function. But now you can go and use that drag and drop line of code, or in our case, a block, anywhere where you want to, and you don't have to rewrite the 20 lines of code. So it makes your coding a lot more effective and efficient. Okay. So that is what function is all about. So now I'm going to move on to this, right? So I told you that they have updated the 2019 version of the Express course at code.org that we were doing up to the 2020 version. And what that basically means is, first of all, I noticed that the entire platform, especially with the execution of the code, has become much smoother. So I'm assuming that they've updated some of the coding languages into some newer versions, or they've actually implemented some updates to just make the rendering of the code much better. So that's very, very smooth. But something else that they've done is, in these more advanced lessons, they've started grouping the blocks according to what type of block they are. Okay, so where we used to have our toolbox, and you'll see this once we get there, where we used to have our toolbox, we would have had a move forward, a turn right block, and a repeat block, and perhaps a conditional or a function or something in there, right? But if we want to have access to all the blocks, it makes it very difficult if you have those ones in the actual toolbox, because there are just so many blocks that if you want to do it that way, your toolbox will be very big and it will be difficult to navigate to where you want to be to. So what they've done is they've made it easier, and they have grouped them together. But before we can actually use these groups effectively, we need to understand what each group is and what the blocks that are under that group will actually do, right? It doesn't help us looking for a repeat and then we go and look at the comments blocks, right? Because that's not the repeat block. So we need to understand that if I'm looking for a repeat, I'm going to go and look for it under the tab that says loops. So I'm going to just very briefly explain what each one does, and then we can have a look at it on the coding platform. So the first one is the actions block. These are these blue ones that we've seen before, and what they basically say is make the character do something. So they will make the character perform in a certain way, either move or turn or pick something or collect something. It all depends on the puzzle that we're on and the actions that are needed. Okay, so they will assign these beforehand. Code.org assigns them. They code these buttons or these blocks so that when we place them in our code, the software knows what to do with them and how to render that. Okay, so the next one we have are loops. So loops is, it makes a sequence repeat. So whenever we have a couple of these action blocks connected together, or we have action blocks connected with in repeats, then we can use that entire sequence with the repeat, place it inside another repeat. Okay, and what a repeat does is it makes that sequence just happen over and over again, a preset number of times. So if we look at these ones are actually conditional repeats, but we'll look at conditionals in a second. But just the normal repeat that we are used to is the one where you can set how many times you want the said sequence to repeat. Okay. So these are also controlled by how many times they can repeat. It all depends on the condition, which we'll speak to when we get to conditionals. So here you can see these are conditional blocks, okay? And a conditional checks for certain things before doing something. Okay, so it modifies the way that the code acts according to certain conditions that are available within the program that's running or within the game that's running. So this one would say, for example, if there is a path ahead, then we want you to do something. Move ahead, move forward as an example. You can place that in there and it will tell this little character of ours that they can move ahead as long as there is a path. This one is going to say, if there is a path ahead, move forward. Otherwise, if there isn't a path ahead, we want you to turn left or turn right. These are very useful when it comes to a puzzle where you are only going to turn in a certain way. Okay. Or if you find that at the end of each path, there is something that needs to be collected, like picking a pumpkin as an example. So you could say, if path ahead, move forward, else pick the pumpkin. So if there isn't a path left and there is a pumpkin, then they can pick that pumpkin. This one is the same as the path ahead, but the condition is just different. This one is for corn, and that one is for path ahead. Now the corn is going to check for corn on the block that the character is standing at that moment. It won't check ahead. It will check on that specific block. Okay. So these ones, I have them here as well. And they only have 2 here. I couldn't screenshot the rest. So I'm just going to jump back, but I want you to see that under conditionals, you will find the loops, under loops, the repeat blocks, but you will also find them, hey, come on, under conditionals as well, because these are conditional repeats. They're not just normal repeat blocks. This is why they are in the loops section or category and not in the repeat category. So this one will say, repeat until there are pumpkins. So this will repeat whatever we put inside until there are only pumpkins left on the playing field. This one is going to say, while there is corn, do this. So whatever we put in here is going to happen as long as there is corn. As soon as there isn't corn anymore, meaning this condition is no longer true, then this action will stop, okay? And then this one is going to say, while path ahead, we want you to do a certain thing, which is very similar to this if path ahead, okay? So we will just play with these 2, especially these 2, on the platform and see how each one acts, okay? So they have chosen to label these, okay? So if I was to use these in coding in a platform of my own, I might have labeled them differently to more specifically identify how this one will work and how this one will work. So we'll just have to figure that out, okay? And then here, the last one we have is functions. The comments one I'll show you on the platform. I'm not going to try and explain that here. So the functions, now we have done functions in Minecraft now since last week. So I hope that you are comfortable with using functions, right? So some functions are predefined and the platform will show you what sequence of code is hidden behind this function. So meaning when we place this check square for corn, what exactly does that mean? Does it mean it is only checking to see if there is corn, or is it telling the character to check for corn, and if he does find corn, he or she has to do something? Okay, so we don't know what this exactly means. We have to look at the sequence to identify what it is going to do precisely. And the next one is the same, get all pumpkins. This one should be relatively easy. It will have something like pick all the pumpkins until there aren't any left. So obviously it will be worded differently, but for now, that is how we can understand it. And then this one here at the top says do something, and then it has an open space. So this is where we can define our own functions. So we can take repeats, we can take conditionals, we can take action blocks, we can combine them into a sequence, put them into this, label this, and then this block will become available in a green block like this for us with the label that what we assigned to it will be what that block is called, and then we can call on that function whenever we need to use that. Okay. So this is obviously a very brief explanation. I just don't want you to feel intimidated. When we get onto the coding screen and you see it looks a little bit different, it can get a little bit tricky, and it does get a bit scary if you haven't seen it before. Right. So now we are going to jump into functions with the harvester. Allow me to switch to my coding screen. So this puzzle 12 was a free play puzzle, and I hope that you all had fun there and that you created something nice with the agent. I don't think I received anything from this class. I did receive from my grade 8 and 9 classes, but if you would like to still do that one and share it with me, you're welcome to do it. You'll see my email again at the end of the lesson. I just want to see. Okay. So I'm going to share the link with you in the chat box, and then I'm just going to explain to you how to navigate this updated graphical user interface, or the GUI. Okay. So while you open that, I'm just going to talk on here for a minute or two, and then we can get to coding. You'll see that I've taken it down so that we're only aiming for about 4 puzzles a day. Okay. And even if we do only 2 a day, I need you to please, if you do not understand, say no in the chat box so that I can review that puzzle and talk on it again. For those that did understand it, it's good practice for them to see it over and over as well, because it can become quite confusing and difficult in the later puzzles if we don't make sure that everyone understands completely at the moment. Okay, so this play area remains the same. There's nothing that changes there. The instructions is the same. The run button and the when run block is the same. Our workspace is limited to 4 blocks. So the only difference that we have is the way that our toolbox looks. Okay, what the toolbox looks like. So instead of having a bunch of blocks here, now we have categories or groups. And when we click on them, you have to click on them. You can't just hover over them. These become available. And now they function the same way as they did before. We can place the move forward block on there, and we can remove it this way. If we want the move forward block again, we click on actions first, and then we find it. So these are all the actions that are available for this puzzle. It might differ from puzzle to puzzle. These are all the loops that are available for this puzzle, right? So repeat until there are pumpkins, while there is corn, and while the path is ahead. There we can see all the conditionals that we have available for this puzzle. Again, these might change as we move along. And most of these conditionals, they have a toggle that you can actually adjust. So this one says if path ahead, if path to the left, or if a path to the right. Okay, and it gives you a little arrow to give you an indication. So all of them are like that. You can set these little toggles. So wherever you see a blue arrow like that, that means there's a toggle you can set. And here are those same repeats that we have there are down here as well. Okay, so we just need to make sure when we are communicating that we refer to these as conditional repeats, because that is what they are. They are not just normal repeat blocks. Okay, and then the last one is the comment. So I've shown this to you before, but I want to talk on it again. So if we are using as an example a sequence that perhaps looks like this. Okay, so this is not an actual sequence. You don't have to code this. You can see I'm already over that. This is just an example. Then we can label this. Let's say in our puzzle we had a corn, move and get the corn, and then move and get lettuce and then move and get a pumpkin. Then we could have called or labeled this as get the corn. And you'll see with this, if we run this, that just gets ignored. This isn't actual code that is going to run within our puzzle. So if we remove this and we set this back, you see we're still on 5 out of 4 blocks there. If we add the comment in there, we're not changing to 6 blocks. Okay. So this is just something, and I want to please ask you, if you are going to pursue coding in any manner, that you use comments. There you can see that is what a comment looks like in the code, right? So whenever we put those 2 forward slashes, and this is true for all of the coding languages that I have used thus far. When you put the 2 forward slashes, you create a comment, right? And this helps you in 2 ways. The first one is for data management. So this will help you to understand, okay, here's the get the corn section. If I want to make a change on that sequence, then I only have to go and look for the get the corn comment, and I need to work on that sequence only. So let's say you have 5 different sequences down here. Junior, this is only an example. This isn't the actual solution for this puzzle. I'm explaining to you what the comment is. Okay. So yes, the goal is to use as few blocks as possible, and that is what we're going to do. But for now, I'm just explaining to you what the comment is. Okay, because we haven't looked at that yet, and this is now something that is available to us. Okay, so let's say we had 4 sequences here for bigger code. Forget about this one now. Okay. I just cannot put this comment block into a PowerPoint and explain it properly. So I want to explain it on the platform. So let's say we had 5 different sequences here doing 5 different things for a much larger puzzle than this. Then you could use a comment for each one of those, okay? And you can see it doesn't matter how many comment blocks I add, it doesn't change the amount of blocks that I'm using because they are not running as code. They are only used as labels, okay? So we want to use them to make sure that we know where we can adjust our things. Another way that a comment works well, not in Blockly, but if you are using line-based coding like this, you can actually go and just put 2 forward slashes in front of any line of code. It will comment that out and that line won't run. So that is a way that we can do debugging, okay? But that is an advanced technique, so don't worry about that. Now we are going to start with this. So we want to move our harvester from here to there, and we want to collect that. So what we are going to do is we need to move forward. And we can move forward again if we want to, but I think it'll be easier for us to just use a loop. Okay, a conditional repeat. So what we are going to say is repeat until there are pumpkins, because we want this to repeat until there are pumpkins. Now, if we test that, you'll see she should walk forward until there are pumpkins. Now, once she gets to the end of this, we want her to pick the pumpkin. So we put this after the repeat. And now you'll see what is going to happen is she's going to pick the pumpkin, and then this repeat. Yes, you just share the link again. There we go. This repeat is now no longer active. It's not being used anymore. The reason is this condition has now is not there anymore. This condition is now false. Okay, so as long as there were pumpkins on the playing field, this repeat would have kept on working. But once we pick that pumpkin and the pumpkin is gone, it is not running anymore. Now I want to see something. I wonder if we can use while path ahead and then pick the pumpkin. Because if we look at the way that this looks, there is a path, and then when the path ends, there is a pumpkin. So the moment that this condition is false, it's not true anymore, this won't happen anymore, then this should happen. So let us test that. Okay. So what we saw there was, I'm going to create the other one as well next to it, just as an example. I know it's wasted code, that it's not being used. This is only an example. So this solution and this solution, they do exactly the same thing, but they're using exactly the same amount of blocks as well. So, excuse me, this one is the one that is active. While has pumpkin, move forward. This one, while is path forward, move forward, then get pumpkin. So you can see even in the line-based coding, we are using the exact same amount of lines. So what I want to tell you with regards to that is that one is not better than the other one for our purposes. Obviously, if we are going to be using these conditional repeats for other uses, one might be better suited than the other one. But for this example, one is not better than the other one. So you can literally choose which one you want to use. And you can also come and play here with these to see if this one will do the same. While there are pumpkins, and then we pick the pumpkin there. So let's see if this one actually does the same. And you'll see it doesn't. It says it cannot harvest the crop from there because you have to actually add a repeat in here to say repeat this. So while there are pumpkins, you need to repeat move forward. Okay. So we will have to just take some time and test these different conditional loops. As I said, if I had the option, I would have labeled this one a little bit differently, but I don't. So we just need to practice using them to see which ones do what exactly, and then we can decide which ones are best suited to use for our example puzzles that we have here. Okay, does this first one make sense to you? Can I move on? I have one yes there. Okay. I'll have to move on because these videos are also going on to YouTube and we don't want these long silences on YouTube. Right. So let us have a look at this one. Ooh, veggies are cropping up everywhere. Now help the harvester to pick all of the corn on the way to the pumpkin at the end. So here we can see it says check square for corn. That is the name of the function. It's labeled as check square for corn, right? We can actually change the label, it seems, if we'd want to, but we do not need to do that. And you'll see that this one is available here under functions. There it is, right? This is just telling us, and this is where we define that function, and this is telling us what that function is going to do. So the function is labeled check square for corn, but it is not only going to check for corn, it is going to pick corn as well. Okay. So we're going to use this to check these stalks that we do not know whether it has corn under it or not. Okay. Now it says here, every square on the way to the pumpkin either has one corn or nothing at all. So use the provided check for corn function to make sure you get everything. So we know that this sequence will work because there is only one corn. If there is corn under one of these, there will be only one. If there is no corn there won't be something else like lettuce or carrots or whatever. It will be nothing. It'll either be corn or nothing. So we can assume and understand that this one is going to work because it is saying if there is corn, do pick corn one time. And we know that there can only be one corn or no corn, right? So what we have to do is obviously move forward, and we have to check the square for corn. So we can test this on that first one, and we can see that it worked. Okay, there's no corn there, but she did check that block because the sprout was removed. Now we need to understand how are we going to repeat this, and we can again have either one of the repeats that we had before. And here you can see this is a conditional repeat, but we have a function inside the repeat, and that's fine. And then right at the end, we want to obviously pick the pumpkin. So they were using 8 out of 8 blocks. So if you only see 4 blocks here, it's because these are also counting towards your block count. Okay, these are actual physical lines of code. If you have a look at this, there you can see there's the function. Okay, and it is an actual, these are actual lines of code that are being written. Okay. Now, if we were to use this 2 or 3 times, then we would be saving on space. Okay, so now if we run this, you can see she's checking for the path ahead very quickly and picking the corn. Go back, don't make me angry. Okay, so she's checking and picking the corn while there is a path ahead, and we can use this one because the pumpkin is when the path finishes. Okay, but there is another loop that we can use, and it's this one that's going to say repeat until there are pumpkins. We can remove that and just put this here for neatness. Now if we run this, you'll see the same thing happens. Okay, so there we have 2 different repeats again that we can use for the same problem and the same to find the same solution. It just all depends on your specific application at that moment when you are going to use it or use one or the other. Right. Do you all understand this puzzle? Okay, one thing that I just have to show you is if you remove this, that function is no longer available. Okay. So the moment you remove the function where you actually define the function off of your workspace, it's not there anymore. It's not available anymore. So then you can just click start over, and then you can do the same thing again, but now the function is available anymore, or not anymore again. Okay. So I only have one student telling me that they are good to go. The rest of you, are you comfortable with this, or is it too complicated? Do I need to explain it a little bit slower? Maybe practice it a few more times? Okay, no input, so I'm just going to continue. Right, let's carry on. Okay. So here we can see we have this function again. So let's read. Use the function to help the harvester pick the corn and the pumpkins. Each sprout will either grow 1 corn or nothing. Okay, so there you can see it's the same as what we had earlier, 1 or nothing. So now we check the function to see if it has been defined correctly, if this sequence will actually do what we want it to do. And it is saying check square for corn. If there is corn, pick corn. Right, so there you can see we have 1, 2, 3, 4, 5 sprouts. So the first thing I actually want to test is if I put the conditional to check for corn on a block where there isn't a sprout, will that give us an error or not? Okay, so it just says don't leave any crops behind. So what that tells me is that we can actually check for corn on each block on the way there. I like that idea because then we can use repeats instead of trying to move forward, pick corn, move forward, check for corn, you know, that type of thing. So now we can start using a repeat. So now I think what we should do is, instead of using a loop, let us use a conditional that says if path ahead. So if the path is ahead, because you can see here it finishes when there is at the pumpkin. If path ahead, we want you to move forward. Else, we want you to turn left. Okay. So let us see if that actually works. Just says don't leave any crops behind. Let us just remove that quickly and see if this is going to, it doesn't do what I wanted to do. Oh, you know what? Let's not use the if path ahead conditional. I forgot. When we use these conditionals, you have to actually put a repeat in there. Otherwise, it's only going to happen one time. Okay? You have to use a repeat block. There we go. That makes more sense. So while there is a path ahead, we want to move forward and check for corn. Okay. The same as what we had earlier, right? And then we want to turn left. Now you can choose whether you want to pick the pumpkin before you turn left or after you turn left. That shouldn't make any difference, right? So here you'll see it's going to pick the pumpkin and then turn. If we do it this way, she's going to turn and then pick the pumpkin. Okay. So that's easy enough. Right, so what we want to do after this is obviously we need to move up here and then turn left again. So we're just going to add 2 move forwards there. 1, 2 move forwards and another turn left. Okay, and we can test this. Okay, now we can either create this again and place it there, which is not a bad idea. So let's do it that way and then see if we can make it a bit shorter. So we're putting this in there and we're going to say, while that is there, do that. And while that is there, do this. And then we want you to just pick the pumpkin. Doesn't have to move again. Okay. So we're doing it this way. And we missed that pumpkin. Okay. Because now it's doing this while there is a path ahead. So here we can see where there's a difference in these 2 repeats. So this conditional repeat is not going to help us. We need to use this one while there are pumpkins, okay? Now, as you can see, even for myself, okay, even for myself, I have to go and have a look at the way that I am going to, I need to test these loops each time to make sure exactly how each one functions, okay? Because just reading what they say isn't always going to necessarily make sense, right? So this one works. Repeat until there are pumpkins. Now I wonder if I can, okay, so this one obviously works. We want to see if we can actually make this one shorter. So let's try to put this entire sequence into this, but then I do think that we're going to have to change that repeat there. So there you see that happens. Turns left. Okay, now we have that same problem. She's going past the pumpkin because we're using this wild path ahead. So let us replace that with this. And 1 pick pumpkin we have to remove. And test it again. And look at that. So that actually works. So here we have 2 conditional repeats, one inside of another, right? That is going to tell this to do this. So the first repeat is saying repeat until there are pumpkins. So it's going to do this entire sequence over and over, including that repeat and the function and these movement blocks, action blocks, all of that. It's going to do that until there are pumpkins, right? So it's going to do that until she is on a block where there is a pumpkin, or there are more than, or there's more than one pumpkin. There are a few pumpkins, right? So this one is repeating to there. And this one is saying, okay, but you still need to do this until there is a pumpkin again. So this is going to repeat this entire sequence until we hit that second pumpkin. Okay. So now we went from using 16 blocks to 13 blocks. Okay, Jesse, if you want to share with me the way you've done it, next time send it to my email, please. I'm very serious about no links in the chat box. I cannot remove anything from a chat box, and if one person posts a link, I know that I can trust you, but I don't know if everyone in this group is who they say they are. So I can't allow you to post links and then not someone else. So please, 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 next time send it to my email, okay? Right. So I hope that this makes sense, and I hope that you can see when it comes to these types of conditionals like we have here, the conditional repeats and these conditionals at the top, we actually have to spend a little bit of time and test them and see how we can use them and make them smaller and better and make the actual sequence as short as possible. Now, obviously, when I am the one creating my own program, I will know exactly what is meant by this statement. If I look at this, I'll know exactly what is meant by that, what is meant by that, and what is meant by that, okay? So here, it might be a little bit unclear, but that's fine. That's why we have the ability to test that each time, okay? So does that all make sense to you? Are you all happy with this? I just want to try and open that without creating issues for myself here. Okay. As I do want to see what you did, Jesse. So I've opened that in a new tab and I'll check it afterwards. Okay. So are you all happy with this? Yes or no? I know it's a lot. I know it's getting very complicated, and that's why we're going to take it slow. Okay, I assume you guys are fine because no one's okay. Angelina says she's happy. Junior went very quiet. Okay, so what I want to do is the next puzzle, let me just have this finish. And then I'm going to, come on. Okay, I'm just going to go to the next puzzle like this. So this puzzle is a little bit more tricky. So I want you to take this link and go and play with this, okay? We will discuss the solution tomorrow in class. Now pay attention. What's different here is the sprouts will still grow one corn or nothing, but we do not know how many pumpkins there are. So where we have used in the past pick pumpkin, we are now going to use a function to make sure that we get all of the pumpkins because there might be more than one. Okay. So do this and then you can create a link and send it to me via email. I'd love to see what you guys have done for homework. And then tomorrow we will discuss that in our lesson as well. Okay, so here you can see we're going to start with number 5 and we're going to aim for number 9. If we only get 5 to 7 done, number 8 is a video, so we won't watch that. If we only get 5 to 7 done, that's okay. This section is extremely important. We have to make sure that you understand this. Okay, so there's my email address. I am going to type it very, very quickly into the chat box as well. So you can, yes, I didn't make any typing errors there. You can copy that and you can send what you've done to me. I'd love to see that. Thank you for being here. Please invite your friends. I'll see you tomorrow, and you can find us on these social media platforms searching for Africa Teen Geeks there. Right, have a great day. I'll see you tomorrow. Bye-bye.